Welcome learners to this third session on aldehydes, ketones and carboxylic acids based on unit 12 of class 12th chemistry book part 2. Now, in this session and in the next session of this series, we will be discussing the chemistry of carboxylic acids. In this session, we shall explain first the nomenclature and the structure of carboxylic acids, and then we will focus on the methods of preparation of carboxylic acids. While in part 4 of this series of sessions, we will first discuss the physical properties of carboxylic acids and then the chemical reactions of carboxylic acids and finally the uses of carboxylic acids. So, let us first know what are carboxylic acids. These are carbon compounds having a COOH or the carboxyl group in their structure, and depending upon the group attached to the COOH group, that is if the group is alkyl or the aryl, the carboxylic acids are called aliphatic carboxylic acids or the aromatic carboxylic acids, as we can represent them by RCOOH or ARCOOH respectively. A large number of carboxylic acids are found in nature. Higher carboxylic acids, which are aliphatic in nature and contain C12 to C16 carbon atoms, are called fatty acids because they occur in natural fats as esters of glycerol. Carboxylic acids are also the starting materials for anhydrides, esters, acid chlorides and amides, etc. After having the general idea about the carboxylic acids, let us understand their nomenclature. We name the carboxylic acids by two methods. One is common nomenclature, that is common names, and the other is IUPAC names. As the carboxylic acids were among the earliest isolated compounds from nature, so many of them are known by their common names. The common names originated from their sources, that is from which the carboxylic acid was isolated or found. In the common names of carboxylic acids, suffix IC acid is written with the Latin or the Greek name of the source of the acid. For example, in the formic acid, the IC acid is coming from red ants, that is the formica, which is the name in the Latin meaning the ant, and the structure you know is HCOOH. And for acetic acid, which comes from the vinegar, the formula is CH3COOH, and in Latin the acetum means vinegar, and you know that in vinegar acetic acid is present. And for butyric acid, which is an acid containing 4 carbon atoms, the name comes from the butyrum word from the Latin language, which means butter, and rancid butter is called butyrum in Latin. So, this acid is called butyric acid. The IUPAC names of the carboxylic acids are given by replacing ending E of the alkane with the oic acid word. For example, if we see the structures in the table here, for the formic acid which is coming from the alkane methane, we replace the final E of the methane with the oic acid and then we get the name as methanoic acid. Similarly, for ethanoic acid, the word ethanoic comes from ethane and we replace the E by oic acid word in the IUPAC name, and in the second column you can see their common names also as acetic acid and formic acid respectively. The third entry in the column shows propanoic acid, which again comes from the propane word from the alkane propane, and we are replacing E by oic acid. Similarly, for butyric acid we can say butyric is the common name and we get the butanoic acid as the IUPAC name. In case of isobutyric acid, you can see that though there are 4 carbon atoms, but the carbon chain is having 3 carbon atoms. So, we name it as a propanoic acid and specifically its name is 2-methyl propanoic acids. Let us now see how the compounds containing 2 carboxyl groups are named. These compounds are called dicarboxylic acids and we suffix the word dioic acid to the name of the parent alkane in their names. For example, for oxalic acid, which is the common name, and the compound contains 2 carboxyl groups, the IUPAC name is given as ethane dioic acid. And if the 2 carboxylic groups are attached to a carbon chain containing 3 atoms in total, then it is called malonic acid as a common name, and because there are 3 carbon atoms now, the name will be propane dioic acid. And it is clear to you now that we are omitting here the final E in the name of the alkane, and we are putting dioic acid as a suffix. Coming to succinic acid, which is containing 4 carbon atoms and 2 carboxyl groups, the name is given as butane dioic acid. And similarly, for the compound having 2 carboxyl groups, the common name is glutaric acid for 5 carbon chain, and the IUPAC name is pentane dioic acid. And you are very familiar with the adipic acid, which is a very useful compound which is known as hexane dioic acid, and it is containing 2 carboxyl groups and a total number of 6 carbon atoms in the chain. Now, coming to the nomenclature of a carboxylic acid having 3 carboxyl groups, the position of the COOH groups are indicated by the Arabic numerals in the names, and the nomenclature, that is the IUPAC name for this compound which is shown here, is propane 1,2,3 tricarboxylic acid, and its common name is tricarboxylic acid or simply carboxylic acid. Now, there are one more category of compounds you are familiar with, which are aromatic in nature, and for them the IUPAC names are given here in the table as well as along with their common names. If you see, the simplest aromatic compound containing a carboxyl group is benzoic acid, and we say that it is the simplest compound containing a benzene ring and a carboxyl group. And if we talk about the second compound, we say it is a phenyl acetic acid as a common name, and in the IUPAC name we called it as a phenyl ethanoic acid. And if the 2 carboxyl groups are attached to the benzene ring, then it is a benzene 1,2 dicarboxylic acids. We indicate the positioning of the carboxyl group on the benzene ring. And now, after understanding the nomenclature of carboxylic acids, let us now see the structure of the carboxyl group. In carboxylic acids, the carboxyl carbon lies in a plane and the bonds on the carbon are at 120 degree. The resonance structures of the COOH group are as shown here. You can see. We will now discuss the preparation of carboxylic acids, and there are several methods which can be used to prepare the carboxylic acids. We will discuss few important ones. The first one is from primary alcohols and aldehydes. Primary alcohols can be oxidized to carboxylic acids using potassium permanganate, that is KMnO4, in neutral, acidic or alkaline media. All the three are possible. Then second reagent is potassium dichromate, that is K2Cr2O7, and the third reagent is chromium trioxide CrO3 in acidic medium, which is very specifically known as Jones reagent. You can see in the reactions that alcohols are oxidized to carboxylic acids using these reagents. And coming to the oxidation of aldehydes to carboxylic acids, even the mild oxidizing agents such as Tollens reagent, Fehling reagent are also used. In addition to them, we can also use nitric acid, KMnO4 and potassium dichromate also for the oxidation of aldehydes to carboxylic acids. The second method is from alkyl benzenes. Here you can see that vigorous oxidation of alkyl benzenes with chromic acid or acidic or alkaline potassium permanganate yields aromatic carboxylic acids irrespective of the length of the carbon chain in the starting material. That is, if we start even with a primary group or a secondary alkyl group in the starting material on the benzene ring, that whole chain gets converted to the COOH group, but the tertiary alkyl groups are not affected by these reagents and we cannot oxidize them to the carboxylic acids. Here you can see as an example that toluene can be oxidized to benzoic acid, and even if you start with ethyl benzene or propyl benzene, we will be getting only the benzoic acid as a product. You can see in the reactions here. Now, alkenes also can be converted to the carboxylic acid, but there should be suitably substituted alkenes can also be oxidized to carboxylic acids with these oxidizing agents. Here you can see one reaction as an example. In the third method for obtaining carboxylic acids, we can start from nitriles and amides. Here, nitriles can be hydrolyzed to amides, which can be further converted to carboxylic acids in the presence of H plus or OH minus ions as the catalyst, and you can see in the reaction that nitriles are first converted to the amides and amides are then hydrolyzed to the carboxylic acids. Similarly, we can start from amides itself and then amides can be hydrolyzed to carboxylic acids. Another method is from Grignard reagents. Very important reagents, very useful synthetic compounds, and these reagents react with carbon dioxide to give salts of carboxylic acids, from which carboxylic acid can be obtained by acidification with the mineral acid. Now, both Grignard reagents and nitriles can be obtained from alkyl halides. Thus, alkyl halides can be a suitable starting material to obtain carboxylic acids. In both the methods we have just discussed, method 3 and method 4, that is either starting from cyanides or from Grignard reagents, alkyl halides can be a very good starting material. Now, there is also one more thing common in these two methods, that we get the carboxylic acid which is containing one more carbon atom in the product than the starting alkyl halide. So, a synthesis can be planned. If you want to add a carbon atom to the carboxylic acid as a product, we have to start with the alkyl halide having one less number of carbon atoms in the starting material. Coming to now next method, which is again a very useful method, we start with acyl halides or anhydrides. Acid chlorides are hydrolyzed with water to carboxylic acids, very common reaction, but these are more readily hydrolyzed with aqueous base to the carboxylate ion, which on acidification can give the carboxylic acid. And you can see in the reaction here. Similarly, anhydrides are hydrolyzed to carboxylic acids with water. Simple hydrolysis, anhydrides yield carboxylic acid as a product. The last method is from esters. We can also carry out acidic hydrolysis of esters, which yields carboxylic acids directly in the water or the aqueous medium, but when we use basic hydrolysis, that is alkaline medium is used, we first get carboxylate ions, which on acidification give the corresponding acids. For example, if we hydrolyze ethyl benzoate, we will be getting ethanol and benzoic acid, and if we hydrolyze ethyl butanoate, then we will be getting ethanol and the acid will be butanoic acid. So, you have now understood the important methods of synthesis of carboxylic acids. There are some questions for you to answer. Which carboxylic acids do you use in your daily life? Name some carboxylic acids of biological importance. Find the mechanism of hydrolysis of amides, and also you can read more about the oxidation by KMnO4 in acidic, neutral and alkaline media. And it will be good to revise by summing up the important points which we have learnt in this program. The common names of carboxylic acids can be related to their sources. The method of naming carboxylic acids using IUPAC rules was explained here for monocarboxylic acids, dicarboxylic acids and tricarboxylic acids. The structure of the carboxyl group was explained. We also discussed the following methods of preparation of carboxylic acids. The number one method is oxidation of primary alcohols and aldehydes, second is oxidation of alkyl benzenes, the third is oxidation, or you can say that hydrolysis of nitriles and amides also gives us carboxylic acids. Then from Grignard reagents, which ultimately started from alkyl halides, and then fifth method we discussed was from acyl halides and anhydrides, and finally from esters. Esters also on hydrolysis yield carboxylic acids. In the next session, that is part 4 of this series on aldehydes, ketones and carboxylic acids, we will be discussing the physical properties of carboxylic acids, the chemical reactions of carboxylic acids and the uses of carboxylic acids. I hope you enjoyed the session. Thank you very much for being with us.